Hi. So this is Aiden. Aiden is CEO of ChainSafe Systems. I'm Afri. I'm working for Parity Technologies. We are doing a short Ethereum 101 session, like getting started, running your own node, connecting to Web3 provider, and yeah, it's basically a very basic introduction to everyone, for all the 42% that are new to Ethereum here. First of all, I'm working for Parity, so I'm kind of biased, but I would encourage people to run their own node, not directly to rely on structure providers, because it's a nice experience and it gives you a better feeling for how Ethereum or how decentralized networks actually work. So for Ethereum, there are different implementations. There's like the official reference implementation, that's GAS, the Go Ethereum client. We at Parity, we developed the Rust Ethereum client, Parity Ethereum. It comes with additional features like multi-chain support or enterprise features like private transactions, different pluggable consensus, and so on. I can dive into it later. And there are many more clients available like Pantheon, Trinity, a lot of different implementations of the Ethereum protocol. So if you want to develop a decentralized application on Ethereum, you can, in most cases, you will just start with like emulating a blockchain environment in a so-called developer mode by running like the different clients you like most in with a preset configured for a developer specifically. That comes without networking and some kind of instant block sealing mechanism that basically watches your actions, and whenever you broadcast a transaction, it seals a block just for you. But at some point you want to step up the game and want to deploy your applications maybe on a public testnet, which is like more close to Ethereum mainnet conditions. Do you want to talk about testnet?
Yeah, so kind of going into the test nets. Oh, we're missing Morden. Okay. So we'll just talk about Ropsten. So Ropsten is currently active proof of work testnet that might be interacting with already. So the reason this is a problem is because proof of work testnets aren't incentivized to have actors acting in a way that's healthy for the network. So it's very susceptible to attacks, spam attacks. So anyone can basically bring down the network. Okay, sorry. So anyone can really bring down the network. And yeah, I mean, for regular developers, most of testing is involving smart contracts and really just deploying some kind of smart contract and just seeing how that works. So the actual mainnet conditions of the consensus mechanism, so having a proof of work testnet isn't really necessary. Where that does become necessary is coordinating hard forks. So for example, during the Constantinople tests that were happening a month ago, or previously, that was kind of done on Ropsten because it's the only kind of mainnet-like testnet. But again, when you're just testing your smart contracts, this becomes kind of a bit cumbersome to developers because they're kind of reliant on this non-incentivized proof of work chain that doesn't really provide you the ability and stability that's necessary to test smart contracts regularly. And because of the spam attacks, literally, Coven was proposed. So Coven is led by, was first implemented in Parity Ethereum and led by a group of people. You can read more about it if you just search Coven proposal. But basically, it is a proof of authority testnet. And this is a completely different paradigm because it is reliant on a set of validators to, as Afri was talking about in the developer, talking about developer mode, dev mode. It's basically sealing the blocks with these kind of trusted validators. So it's a bit different from a consensus perspective than the mainnet, but it really provides the stability and the usability that is necessary to actually test smart contracts, as opposed to testing consensus, hard forks, and just different EIPs and stuff that would be necessary in the proof of work world. So the really kind of cool thing about Kovan is that it supports PWASM. So right now you can deploy Rust smart contracts to the Kovan testnet. There's a really cool tutorial on deploying an ERC20 in Rust that I highly recommend. It's a cool feeling to do that. And yeah, so because of these features that aren't available on other clients, this testnet is siloed off and only usable within the Parity Ethereum world. So whereas Ropsten is cross-client, Kovan only works within the Parity Ethereum context. So this also stops us from being able to test certain things, and it also just stops us from having a reliable and consistent testnet in the case of its clients not being able to actually run the network itself. So in response to Rinkeby, in response to Kovan, Rinkeby was proposed by Peter from the Geth team, and basically it's as well. Okay, so going backwards, Kovan runs authority round as its proof of authority consensus mechanism, whereas Rinkeby runs leak. So they're very similar. There's a couple different nuances that are different. If you're interested, please come up after, ask some questions. But it's small things, really. Really what makes them super unique is the feature sets of the clients themselves. So PWASM is the one. And so these testnets could never really come together because PWASM support would need to be Pantheon, Geth, and a whole bunch of clients. So in response to that, Afri and I just started talking a lot, and because he is very open with communication and very transparent about what he does, I learned about a cross-client testnet being a problem. Up until then, never really thought about it, never considered it, and then I see a comment that he made on GitHub. It had been an open problem for a year, that there was no cross-client proof of authority testnet. Doesn't sound very sexy, but it's a real problem. And so what we did was at ETH Berlin in September, we worked on implementing Aura into Geth, which now done the opposite. So at the time we had kind of issues with writing Rust. Our team writes Go. So we attempted to go. Sounded funny. We attempted to write it into Geth, Aura, and it didn't really go too well. So we reset it and have now, with the help of the community, been able to implement it now in 5 different clients, and it is live now. It's been live since January 31st, where we pushed a red button, started the testnet at GirlyCon, Berlin, and so that was super exciting. Thank you to the DoD for hosting that. But yeah, why does this matter? Why does a cross-client proof of authority testnet matter? And it mainly comes back to usability and developer friendliness. If you do not have a consistent testnet up and running that is always available, will encounter issues. So for example, when we were working on this project at ETH Berlin, Rinkeby went down for a short period of time. So this is something we don't really consider often, but what happens when that happens, right? We're screwed, basically. So a cross-client testnet ensures that there's stability within that network because of this kind of multi-client paradigm where if they're making sure that their network is always running.
So yeah, similar to the developer presets, most clients support presets, pre-configurations for public testnets. For Girly, for instance, it's like gas --girly or parity girly. the parity pull request is not merged yet, so it's like soon TM, but we are getting there. So yeah. So now that you want to develop on the testnets, you probably want to send transactions, deploy contracts, or just connect whatever you are developing to your local node. You, in most cases, want to enable RPC APIs. In most cases, you use HTTP, probably, but there are also some clients implement WebSockets or IPC APIs, so you can just go for whatever you want. Default HTTP or RPC port is 8545, as you change it. So if you want to get started with Girly testnet, for instance, I mean, we are biased because we launched it, but we would recommend you to use Girly. We have different block explorers. We have Block Scout, we have EtherScan, we have a status dashboard, we have different faucets, we even have a bridge, so you can bridge your old legacy testnet coins to Girly if you don't need it anymore. So, yes.
So just like, we're not trying to say that proof of work testnets don't matter. They really do matter, and we need to incentivize people to mine them and actually be a part of that network, and that's why we created a bridge that allows you to bridge up to 100 ETH. So if you want to go and mine, so with proof of authority testnets, there's a pre-allocation, so you do not get testnet ETH for validating a block. So the only real way for us is to use the faucet or to bridge from any other testnet. So we highly recommend that you go out there, you get involved in the testnet, then bridge that over to Girly, burn that Ropsten did anyway.
Yeah, bridge. We came up with a bridge idea in Prague. It was pretty nice. So if you're lazy and don't want to run your own local node, you can just connect to public RPC endpoints or public APIs. Block Scout, Prismatic Labs, and some other people are running public RPC endpoints. Infura has just announced this week Girly support, so you can use Infura for Girly. We've written a tutorial how to spun up your own nodes with Terraform. And yeah, we have more resources. Now we are getting interactive. Just walking through, like connecting MetaMask to a local Girly node, creating an account, sending a transaction, requesting Girly testnet Ether. So MetaMask is a browser extension that allows you to manage accounts, basically. Yeah, Paris. Are you running a local node right now? No, okay, so you use the public, okay. So show it. Yes.
So yeah, if you open up MetaMask, and so you can see already here that I'm connected to a custom RPC, and you can see here localhost. So if you're running it locally, so yeah, you would very conveniently just hit up the custom RPC. You very conveniently will do that and connect to one of these endpoints. Oh, hit H. just like that, you will be, oh, maybe it's not HTTPS. Or maybe it's just down. Yeah, it's better to run your own node for sure. Yeah, it seems like it's not working. Interesting. I'm going to definitely try it. It'll all eight, just 8. I mean, I tried HTTPS before, so it's having issues, but whatever. I don't really want to deal with it. Yeah, so I already am connected to a custom RPC. The open endpoint here. And yeah, very quickly I can go to just I could go to the bridge, but I'm just going to go to a faucet just because it's a little bit more convenient. And just like this. Sorry, I'm going to use the other one because it's not social.
So we have 2 faucets. One is like throttled, so you can just enter your address and get like a small amount of ETH, which is enough to cover transaction fees. This is this one, and we also have like a authenticated faucet where you can like authenticate yourself with a social media account to get like a bigger chunk of ETH, of testnet ETH. That's to prevent spam, obviously. And it's pretty straightforward. You just fill in the captcha and the address, and you get like a very small amount of testnet ETH, which you can use to send transactions, deploy contracts, interact with smart contracts, bootstrap your decentralized applications. Yeah.
How a faucet works. It's pretty simple. To anyone who hasn't interacted with one before, if you have any questions, please come up to us. We'd love to help you get started. And then it's as easy as sending ETH. I'm just going to send some to myself. Sending some here. And it really is that. Yeah. If anyone needs some ETH, I might know a guy. So it's as simple as that. So send some Ether to the one account, from the one account to the other. There are no transactions, but it'll come up eventually. And it really is that simple. Again, please, if you have any questions, please come up to us. We'd love to help you kind of getting started with deploying contracts. Any questions in general regarding testnets? Yeah, we'd like to talk about this stuff, unfortunately, for us. Yeah.
No, I guess that's what we showed already. Show the cat picture. Okay, thanks. Question? Question? Oh yeah, sure. Easiest is if you go to the github.com/girly/testnet. This links all resources. It's the best resource, probably. Yeah? Oh yeah. Oh, there's a GitHub faucet. Yeah. That's a mess. Yeah, but to be honest, so from a core developer perspective, Robson will most likely be retired at some point, maybe this year, because it's like not sustainable anymore. It's like a huge blockchain. The blockchain of Robson is bigger than Ethereum Classic, you know. I don't know what the plans for Coven is, even though I work for Parity. But I know from Peter that also Ringby is like growing to sites where you actually just want to reset it, and having Girly now is like also for the guest team a good chance to just say, okay, we can now like deprecate Ringby. So it's not like we adding one more testnet, but we like offer like a solution that might replace existing testnets to some degree.
Just even the robustness of testing that has come from Girly with things like Nethermind and Pantheon has been incredible to see. We're able to test things now within a proof of authority testnet paradigm that otherwise you could not have done. So it's super exciting from kind of the more boring kind of side of things, I guess, not as sexy side where, you know, test cases are more robust now. But just as well, you know, like ENS just supported Girly with all of their, with everything. Ethers.js just supported Girly Pura like a couple days ago. So the community has, and my Wallet, Block Scout, like, yeah, people have really moved towards it. And we're hoping that, yeah, this is a way to not have to worry about having 14 different testnets. Thank you very much.